This demo gives a brief introduction to the frequency planner and loop filter design tool available in the latest version of the CDCE62005 GUI. As you can see, I am running this tool without an EVM connected. When the EVM is connected, it is helpful to go ahead and check the two boxes in the EVM status window to get real-time feedback while you work. The first step in creating a new setup is to start with the frequency planner. Here you simply put in a target output clock frequencies you want to generate from a given input. This 66.67 MHz frequency is actually pretty common, but is not easy to generate with integer dividers. So if we give it a little margin for error, we can achieve something very close. Here you can see that there are several possible solutions, and here we'll take the first recommendation and apply it to the GUI. Once we apply the settings to the GUI, the dividers are all set up for the desired frequency plan. We can now set up the different input and output buffers to drive the needed signals. Let's look at a couple more common examples using the frequency planner. You might see some of these frequencies in applications like SerDes and Gigabit Ethernet. At this point, we are ready to configure our loop filter. Now, if you are not familiar with how to set up a loop filter, there's a nice help file available that walks you through the steps. The CDCE62005 has options to configure the loop filter for either internal or external components. Internal component values are often good enough to generate a wider bandwidth in the case where the input reference clock is from a clean, low jitter source, like a crystal. When the input reference clock is high jitter and requires jitter cleaning, a low bandwidth is needed. In this situation, the better option is to use external loop filter components for the loop filter because larger capacitive values are available. In this example, we'll first generate an internal loop filter. We enter the desired bandwidth, and once we find the RC values we need, we can proceed to simulate the filter. There are different plots available, and the graphing tool allows you to click anywhere in the curve to see the X and Y information. We can also save this curve in the background for comparison later. Now let's try to get a much lower bandwidth using a loop filter with external RNC components. We want to click the checkbox here if we want to restrict the recommended components to standard values. Once again, let's look at the closed loop response. Here we see our previous filter in the background and can compare between the two. We hope that you enjoyed this demo and have fun creating new clock solutions using the 62005.